And if I could like sum this unit up in just a formula, I would say obviously this isn't everything. But that is what this whole unit kind of revolves around. And you're like, even the converting stuff, technically even the converting kind of revolves around this idea, right? Converting units. Because if you're given a scale factor, the scale factor is actually quite often derived from a rate, right? And then we just cancel out the units, but this actually came from a rate, right? 2 centimeters is 3 kilometers in real life. That is actually a rate, and we just make some conversions to just get it into like a number. So this is actually a rate, and new original, you got to keep that in mind. And obviously I gave you the diagram over actual as well, right? The other version. When I deal with maps or pictures or blueprints, I tend to use those words rather than new and original because it's easier to see which one goes where. Okay, so let's just get right to it. What's the scale factor used as a percentage? So we know that this is it as a fraction. If you divide this and multiply it by 100, you get 150%. How is that? 1 mark right there, just to get started. Usually I don't record the ACs, but I think I'm going to do this one because you can look it up as review. Okay, what's the new length? So using the scale factor, obviously they want the new length, right? So that means that the original is given, and so that's 15 like that, right? So it's basically just cross multiply and divide. So that's 15. Just show me this work, right? And we get 22.5 centimeters. So if you have that answer, you would get a mark. On a test, I would want you to show the work. For today, if you came up with that, you're okay. Similarly for the new width, right? If I find the new width, I'm going to start the exact same way. So width of the new and the original is 2 centimeters. So the width is 2 times 3 divided by 2, which is just 3 centimeters. If you have that, you get another mark. And now where I really want to test your knowledge, see if you're starting to get more in depth here. How much greater will the new area be? And the answer is it will be k squared greater. And you're like, what? Right? Because the area of any shape, you take the scale factor that all the dimensions were changed by, right? And we remember when we did the experiment, right? It showed you, hey, let's find the area and let's divide them. And we ended up saying that it was k squared. It was affected by k squared. So that's 9 over 4. Or if you rather state that as a decimal, right? 2.25 times. Okay, it's up to you if you want to go 9 over 4 or that. So that's a mark right there. If you're sitting there, it's like, well, I figured out, because remember, a scale factor can be stated as a fraction decimal percent. Right? If you turn this into a percent, what would that be? 225, right? Percent. So you can also say that the new area is 125 times greater, 125% greater than the original, but the actual areas have been affected by k squared. This is what I prefer you say, okay? That's a mark right there, 5. What about the volume now? What will it be affected? It will be k cubed times greater. Okay, so you take your original scale factor, you cube it. 3 cubed is 27 over 8, right? So I know some of you probably this is what you did, and that's okay, but it's more time consuming. You took the new, you know how you found the new dimensions, the new length and the new width, right? You multiplied that, and then you perhaps divided the old area and the new area, right? You come up with the same answer, right? But I would like you to immediately jump to this, right? Oh, area will be affected by k squared. Volume will be affected by k cubed, right? Automatically. All right, so 1 mark for that as well. Let's switch over to the other ones there. So question 9, true or false? An object was enlarged with a scale factor of 3. This object's area would be 6 times greater than the original. True or false? Okay, you're like, I don't know. I'm just guessing here. Well, let's look at area. So that's k squared, right? So then we need to look at the original scale factor. That's 3. So the areas will have been affected by 3 to the power of 2. So that's 9. So that it's actually false, right? The answer to that is false. It's actually 9 times. If it had been 1/3, then it's 1 over 3 squared, so it'd be 1 over 9. That's how the areas have been affected. Okay. 10, true or false? So this is 9, right? For question 10, true or false? An object was reduced using a scale factor, that's important, 3 over 4. The new volume will be 9 over 16 times smaller than the original. Let's try that out. We're talking volume, so we have to cube it, so that'd be 27 over, what's 4 cubed? 84? Sorry, 64. Is it Monday? It's Tuesday, but it feels like a Monday. So this is the answer. So it's actually false, right? It's actually false, and I'm kind of testing you. I'm like, oh, I'll see if they square them. Maybe they'll square both. It's 916, and you feel like it's right. But this word right here, volume, tells you this is a cubed chain, right? Everything is affected, so there are 3 dimensions involved here. Okay. Next, 11. Okay. If the original shape has an area of 43, very important, the wording, right? This is one piece of information right there. Original area, and the new area here is 688, right? The new. What scale factor has been used? So you look at your study sheet, right? And you're like, this is areas. So this is what I'm going to start with. K what? Squared. Yeah, exactly. So many students miss that, right? So k squared is area of new, area of original. So they're asking you to come up with a scale factor, but you need to start off like this. And so I'm going to go ahead and say k squared is 688 over 43. And you can write down see the units, guys? If you see the units and it's a squared unit, you automatically should have a 2 there, automatically. So there's a bunch of things that you can kind of have in place to make sure you get it right. And at this point, you cancel the units, which is exactly what you want. To find k, what do I need to do? I need to square root this whole thing. And here I'm going to introduce a word of caution. You need to be careful how you type this into your calculator. Quite often the calculator catches it, but I will show you here. So you have 2 options. You go second x2 to call it, and then I will go bracket 688 divided by 43, close the bracket. So that you make sure that the calculator divides first and then take the root. There's a chance that you got it right anyways. Okay, so the answer is 4. Okay, the answer is 4. No units, right? So I would say this. If you actually start off your setup with a k squared, you already get 1 right off the bat. If you then go ahead and find the right answer, you get another one. So two marks for getting the 4, because you need to set it up properly and you need to actually take the square root. This is question 11. Question 12. Okay, volume. The original volume, I'm being so clear here, right? Like I'm telling you, this is the original volume. The new shape has a different volume. Both of them are a meters cubed. That's perfect. What's the scale factor? So volume tells you that you're going to start like this. Volume of new, volume of original. You don't know what the scale factor is. That's what they're asking you for. So just plug in and go. The new is 100 and the original is 2700. I will not put the units down because I think you get it at this point. Let me just move this up a bit. There. So what do I need to do now? K is cube root. Make sure in your notation, this would be a notation error if you don't put the index of 3 there. Otherwise, you're telling me it's a square root. And so it's 100 over 2700. You can cancel zeros. Yeah, you know, remember that, right? I won't do that because that's not the point right now. So watch how I'm going to enter this. You go math, fourth option, right? And then just make sure you have brackets in there. 100 divided by 2700, and that is 0.333 repeated, which is also 1/3 if you prefer. If you go math fraction, it will turn that into a third anyways. The question doesn't specify, just give the decimal. All good. And so again, a mark for setup, a mark for correct final answer. So you get 2 marks there for that. Okay. And question 12. State a value of k that would result in a reduction. So this is there are so many right answers here. So you could do 1/2, 0.003. You can go anything that's less than 1. You can go 8 over 9. You can go 85%, right? Like anything that's under 100% or under 1 or a fraction that's less than 1, right? K is less than 1 is the key to answer this one correctly. Or K is less than 100%, right? It's the same thing. We're saying the exact same thing. So there you go. Let's get the marks right. So let's go back to our mental math here. So this is 1. We've got 2, 2, right? And the true and false, they're each worth 1. So let me just zoom out here and get this right here. Okay. So put whatever mark you got next to the question, right? And then the first 4 here, or 5, I should say, would also, that would be worth 5. 1 mark for each correct answer, 1 to 5. So what are we at here? I think it's 12. Total is out of 12. Make sure your first name and last name is on there. And then pass it forward and get your notes out. Just put a mark down. If you want me to check it, just